welcome back. In the previous video, I showed you how to fit a linear curve fit to some data points, and we found out that those data points were in fact linear, and the residuals were 0, and it fit great. Here I've defined a different set of data, and looking at the data plotted here, it doesn't look terribly linear, so we're going to try a non-linear fit. So this is going to be very similar to what I did in the last video. If you didn't watch that first, because I explained some of the preliminaries there. So we're going to say y1. Now y1 is the y value in the table here, right? If this is y3, I do y3. And we're going to say, well, that's approximately equal to a, and I'm going to do a quadratic fit, all right? So let's do a times x1 squared plus b times x1. Let's try that again. B times x1 plus c. It's a quadratic function, so I have 3 parameters. And you can see that this is not a bad looking curve fit for these data, right? The R squared value is 0.999, okay, which is pretty close to 1. So it's a pretty good curve fit. The parameter values are listed here. And I'll show you, we can go ahead and write that function in just a moment. And I mentioned the residuals in the previous video, so let me continue with that here. Here's the residuals. You see the residuals are not 0 here like they were in the linear fit. There's some non-zero value, and they're plotted down here about the x-axis, but they're pretty randomly distributed around the x-axis, plus and minus, which is what you would expect for a good curve fit. And so these residuals are quite low compared to the values of the points, right? And all these residuals are the y values that by which the data point value, the data point y value, differs from the y value of the function for that given x value. All right. Now, if I want to reproduce this function here, I'm going to say, well, y equals ax squared plus bx plus c. And there I have that. And maybe I want to limit this function so it's displayed only from 0 to, I don't know, let's say 100. All right. And there we have it. I'm going to turn this off. And you see there I'm plotting the 100's kind of way out there. Now let's do a 60 here. There we go. All right, so I just limited the plotting of the function for x values between 0 and 60. All right, so that's curve fitting a quadratic. See some data. Why did I choose a quadratic? Well, it didn't look linear, so I thought I'd bump it up 1 degree and start with a quadratic, and it looks pretty good. My R squared value is pretty good. If I have a function maybe that turns back on itself, maybe I want to try a cubic function, and I would do that similarly here, except I would say, well, a times x1 cubed plus b times x1 squared plus c times x1 plus d, and Desmos would go ahead and fit a cubic function. All right, thanks a lot. I encourage you to reproduce what I've done here on your own in Desmos. You're going to learn much better that way than if you just think you've really grasped it all from watching me do it. Learning comes from the doing, not the watching. And that if you need to take a look at the video, if you get stuck, I'm here. All right. Thanks a lot. Take care.